ICADEIS 2000. Let me introduce myself. My name is Diya Namira Purba, and I'm from Astra Tech Polytechnology, and I'm honored to serve the moderator for this session. Today, we have a series of remarkable presentations that will explore briefly some many topics that will be presented. Before we begin, allow me to outline the format of the session. Each presenter will have 10 minutes to deliver this presentation. So each of you have 10 minutes for present all your paper. Each presenter has the maximum 10 minutes at the present, and at the 8 minutes, there will be a reminder that there are 2 minutes left. So there will be a reminder in the first 8 minutes, and then after that, the reminder will 2 minutes left. At the 10 minutes, I will state the time is up. So you must finish your presentation at 8 minutes, and it's better than less than 10 minutes. 5 minutes of question and answer segment. Okay? And then for the orientation, maximum 15 minutes per person. And then I'd like to remind all the presenters to just already display them into your paper ID and following with your full name. Okay? And then don't forget to use the virtual background for each session. Now, without any further ado, let's welcome our presenter. So we will begin for the first presentation. And the first presenter will be with the title paper of Seamless High Availability in MySQL Database System and Advanced Implementation of Proxy SQL, presented by Mr. Jeremy. Mr. Bridges. And then the next presenter will be presented by Miss Namira with the title Implementation of Semantic Search Based on Vector Database for Personal Documents. Okay? And then for the first presenter, I want to confirm you will be sharing your screen, or would you prefer to present with our team help?
I prefer to present my own.
Okay. So let's begin for the first presentation.
Okay. Okay, is my screen already shown?
Yes.
Okay. First of all, thank you for the opportunity to ICADEIS and the ICADEIS committee. My name is Jeremy. Good afternoon, everyone. I'm here to present my paper on seamless high availability in MySQL database systems, an advanced implementation of Proxy SQL, Orchestrator, and Keep Live. I'm Jeremy from Bina Nusantara University, and my advisor is Professor Benvano Suito. So I will start from the introduction and the background. First of all, I'd like to discuss about database. Yeah, so database server is used by applications to store vast amount of data, lots of amount of data, and it is a critical component for data-dependent applications. Unfortunately, there are some potential issues on database servers. Some of them are server downtime due to hardware or software failures and disruption of application services relying on the database, and which these issues can cause an financial impact up to $5,600 per minute, according to a research by Gartner. This downtime, yeah. Therefore, the solution to solve these issues are by implementing high availability systems. And implementing high availability systems can bring some challenges, including seamless failover, maintaining data consistency, and efficient communication between servers. The initial solution is to increase availability by adding redundancy. And the challenges like data consistency and load balancing among servers will be added to prevent overloading. So the objective is to propose a robust, scalable, high availability database architecture. Here are some previous researches that we have reference. As we can see here, the previous researchers have brought a good foundation to my research, to our research here. But there are some issues to solve here, including single point of failure. We have a lack of redundancy in the orchestrator or proxy SQL implementation, which will be the load balancer, and the scalability concerns, and inefficiency in query routing or when it is used under heavy loads, and delays such as database locking, slow detection and response to node failures. These are some previous researchers. Therefore, the proposed solution is to have a redundant database, of course, with a master-slave setup and query splitting for efficient load balancing. And the load balancer should eliminate the single point of failures too. So the load balancer will not only be one only. And also the automated MySQL cluster manager. This should be also redundant. And there will be keep alive. Keep alive is for managing virtual IP. So the client will only have one access door to access the database. And the scalable topology supporting additional nodes without significant reconfiguration. The key benefits are seamless failover, efficient load balancing, and consistent data replication across nodes. The research methodology, here is the proposed architecture. As we can see here, the client will only know one IP address to access the database, while the backside of the system will have at least 6 servers. The orchestrator and proxy SQL will work as the load balancer and the topology, the cluster manager, and this will be will be made at least 3 servers. So therefore, if the first one is down, it will be backed up by the second or the third one. Also, the main database server, there will be 3. The first one is the master server, and the second and the third one will be the slave server. Means the anything will be written to the first server, and if you want to read from the database server, it will be from the slave, which is MySQL2 and MySQL3. This will be replicated from the MySQL1. Okay. So the implementation steps, we have the database setup, orchestrator integration, proxy SQL configuration, and keep alive setup. To test the topology, we have the high availability validation to check the HA, the failover, the load balancing, and the virtual IP failover, and the replication accuracy. And the result, the high availability, master failover time. This means when the master database server is down, to make the topology recover again, it took about 8.36 seconds. Yeah. And the client query success rate is about 100%, and the data consistency is maintained. The load balancing about almost equal, 5,000 queries between the MySQL2 and MySQL3. Query means for the select only. And the average response time is about 5 milliseconds. The virtual IP failover is about 2 seconds, which this made a seamless reassignment of VIP. Virtual IP ensures uninterrupted client access. And the replication accuracy, we have tested the operations to insert and update records, or all the data are consistent. The conclusion, so this research combines the proxy SQL, orchestrator, and keep alive for a robust HA, high availability. We have also demonstrated seamless failover, load balancing, and data consistency. And the future work, we should test under many downtime conditions and more cost-efficient and resource-efficient optimization for lower resource environments such as maybe IoT. Also, the failover time, it can be shorter or it can be quicker. As we can see here, it's about 8.36 seconds. But the topology actually works, but the issue here is the time is 8 seconds. It could be quicker. Okay. Thank you for listening to this presentation.
Okay, thank you for Mr. Jeremy for the experience and insightful presentation. We will now open the question and answer section. If you have questions for other presenter, if you want to ask Mr. Jeremy about his research, please use the raise hand feature in the Zoom and kindly state your name and the affiliation before asking your question. Each of you have 5 minutes for question and answer section, okay? Okay, I think there is no question from other from the audience. So I will ask for Mr. Jeremy, okay?
Yeah,
So,
sure.
okay. My first question is a basic question when we do a research. What is your challenge when you do this research?
Yeah. Thank you for the question, Miss Diya. Yeah. For this implementation, the challenges are having lots of servers because we try to implement this in a virtual environment, Proxmox virtual machine. We have about 6 servers here and should be implemented in a Proxmox virtual environment. The challenge here is to manage about 6 servers. This is very frustrating because the numbers of server is about 6. Yeah, we should configure for each servers. That's one, and also the challenge. Another challenge is to make the failover time quicker. This is the fastest record that we have tried. We record this using a benchmarking tool, Sysbench, yeah, and I believe this can be quicker in newer research later on. Okay, that is my answer.
Okay, thank you for your answer. So the second question may be, how does or what are the performance impact of using proxy SQL orchestrator and keep alive for seamless failover in my SQL cluster?
Yeah. Okay, thank you for the question, Miss Dia. The impact, of course, by having a high availability architecture, it will minimize the downtime of the servers. As we all know, the database server will store a lots of data, including confidential data or also maybe important data that affects the business process of a company, for example. Therefore, by having this architecture, at least we have the data can always be accessed, uh, can always be available for the client to be accessed. Okay.
Okay, thank you for your answer. Please applause everyone for Mr. Jeremy presentation.
Yeah.
Thank
Thank
you.
you, ICADEIS committee.
Okay, thank you. So everyone, we will continue for the next presentation that will be delivered by Ms. Namira Salsabila with the paper title Implementation of Semantic Search Based on Vector Database for Personal Document. Is there Ms. Namira in here?
Yes, I'm here. Is my voice clear?
Yes, very clear. Are you want to present the presentation by your own self or with the help of the team?
With my own.
Okay. So the time is yours and we have 10 minutes for the presentation, okay?
So, is it already?
Yes, it's already present on your screen.
Okay, but I'm sorry, can I change my Wi-Fi because
Oh, okay. It's okay.
I'm sorry.
You have 9 minutes. You still have time. Okay, so let's continue. I think are you done, Miss Namira? Are you need more time? Do you need more time? Okay, so I think we will skip to the next presentation. Miss Namira can present after this presentation. Okay, we will continue for the next presentation with the paper title Enhancing Python Object Relational Mapping Performance Using Just-in-Time Compiler, that will be presented by Mr. Aldi Setiawan. For Mr. Aldi, are you present?
Okay.
Okay, do you want to present the presentation by your own self?
Yeah, I will present with my own self.
Okay, so you have 10 minutes for present your paper, okay?
Okay. Okay. My screen is already present.
Yes, it's already present.
Okay. Okay. Thank you for the time. My name is Aldi Setiawan, and then I will present about enhancing Python object relational mapping performance using just-in-time compiler. I start from introduction. So object relational mapping or ORM is technology that simplify interaction between application and database by allowing the developer to work with database using object instead of writing raw SQL query. ORM enhance productivity and maintains clean, structured code for database-driven application. However, one of the major challenges with Python-based ORM framework is their suboptimal performance, especially when handling large dataset. As data volume increase, traditional ORM often experience slower execution time, high memory consumption, and increased CPU usage, impacting application scalability. To address this issue, this is research introduces S.Kom, an ORM framework that integrates just-in-time compiler to optimize execution time, CPU usage, and memory consumption. By leveraging just-in-time compilation, S.Kom aims to enhance the performance of Python ORM frameworks. And then problem statement. The key challenge addressed in this research is a performance limitation of Python-based ORM framework, which often struggle with execution speed, memory efficiency, and CPU utilization when dealing with large dataset. To overcome this limitation, this research focused on integration just-in-time compiler into ORM framework to enhance their efficiency. Just-in-time compiler allow to the data mapping process to be compiled in real time and reducing interpretation overhead. This study evaluate the extent to which just-in-time compilation improve ORM performance by measuring its impact on execution time, memory usage, and CPU utilization. Okay, and then research methodology. The methodology for this research is divided into several case steps. First, the research design overview outlines of the object and scope of the study. And then a development process focus on building the S.Kom framework with just-in-time compilation integration. And then this followed by framework comparison where S.Kom is tested against established Python-based ORM framework. For consistency, all tests are conducted within standard setup environment using Docker container with container resource. Then performance evaluation is conducted to measure execution time, memory usage, and CPU efficiency across various scenarios. Finally, analysis of result provide insight into effective of S.Kom compared to traditional ORM framework. Yeah, this is in the picture we can see the fundamental working mechanism of object relational mapping in Python. ORM serve as bridge between Python object and relational database, allowing the developer to interact with database using Python class and object instead of raw SQL query. The process begins when a Python object represent database record is created or modified in application. The ORM automatically translate in this object into corresponding SQL statement, such as insert into, update, or delete. Depending on the operation performance, this SQL statement is then sent to database for execution. And as database process the query, it return a result such an auto-generate ID for newly insert record or number affected row and update or delete operation. The ORM then maps the result back into Python object, making it easy for developer continue working with data in object oriented way. Okay, and this my solution flow. So the workflow begins with user intent query to map database on a private object model. The system first check for a precompile module in case if available, it directly executes that case module, saving time and resource. If no precompile module if is found, the system generate an LLVM intermediate representation, which is then compiled into optimized machine code tailored to system architecture. This compile module is stored in the case for future use, enabling the faster subsequent operation. The just-in-time compile code is then execution, transform raw data into ORM object model format through an efficiency mapping process. And then this is the result of my research. The performance evaluation result for execution time, CPU usage, and memory usage in environment with 0.2 CPU core and 512 megabyte memory. This result demonstrates how different ORM framework perform under constrained system resource, particularly when handling large data operation. Execution time analysis show the S.Kom consistently outperforms traditional ORM framework, especially in book creation and list retrieval operation. The integration just-in-time compiler in the data mapping process allow to S.Kom process large data set more efficient. And then in terms of CPU usage, the result indicate the all framework exhibit similar resource consumption with average CPU utilization remaining relative consistent across different ORM implementation. This suggests that CPU usage during CRUD operation is relatively stable, making it difficult to draw significant conclusion regarding CPU efficiency among framework. Regarding memory usage, S.Kom demonstrates lower memory consumption compared to other RAM, particularly in book operation. This is of efficiency in attribute to its compiled data mapping, which reduce memory overhead and ensure more optimal resource allocation. And for conclusion, in this research, I will summarize the key finding based on performance evaluation and feedback gathered during the study. First, performance evaluation demonstrate that S.Kom consistently achieve high performance across critical metrics like response time, CPU usage, and memory consumption, particularly when handling large data. And then just-in-time compilation advantage lies in the ability to.
Mr. Ardi, you have 2 minutes left, okay?
Okay. I will continue. Let's just-in-time compile advantage its ability to pre-compile mapping process, reducing runtime overhead and mirroring the efficiency since a compile language. And then context-dependent performance, while S.Kom excel in the large dataset operation framework like Tortoise ORM essentially perform in the smaller dataset scenario, particularly in list retrieval tasks due to their optimized querying process. This underscore that no single ORM framework in universally optimal, and performance depends on specific environment and workloads. And then developer feedback is it was found the GTOM integrates seamlessly into development workflow and offers easy of use. However, this framework only provides basic feature requiring further enhancement to support more complex use case effectively. And then less feature work. This is research suggests continue to development of GTOM by adding advanced functionally and condition intensive user feedback evaluation to refine its scalability and applicability for a broad range of application. Okay, maybe that's all from me. Thank you.
Okay, thank you from Mr. Ali for the presentation. And then we will continue to the question and answer section. For the audience, you may answer Mr. Ali about his research presentation. And for the question and answer is 5 minutes duration. Please use the raise hand feature in the Zoom, and the question and answer section only have 5 minutes duration. Okay. So let's start the question and answer section. Is there any question from the audience? No? Okay, so maybe the question is from me, yeah? Okay, the first question. What are the key challenges when you implementing the just-in-time complication for Python ORM performance optimization?
Okay, for my challenge, yeah. Okay, maybe I have a challenge about force integrating of this just-in-time compilation in ORM framework. The implement just-in-time compiler into ORM framework required a significant modification to the traditional ORM workflow, unlike standard Python ORM that really on a direct interpretation of query. GTOM introduced a compilation step during data mapping, which add the complexity to implementation. Because just-in-time compiler not have flexible data type of data different with Python native, and then balancing initial compilation of rate and runtime efficiency. So one of the threat of just-in-time compiler is initial of rate required to generate and compile LLVM intermediate representation. The challenge was to ensure that this initial delay does not negatively impact overall performance, especially for application with frequent short-life transaction. And then research constraint in the testing environment. The research was conducted in constraint testing environment to evaluate ORM performance under real-world limitation. So I use two environment. First, 0.20, 0.2 core CPU, and then second I use 0.5 core CPU for the detail in paper. I think this is my challenge for my research.
Okay, thank you. And the second question, how does the JIT compiler, JIT compiler compare to the traditional query optimization technique in improving Python or efficiency?
Yeah, actually, I use just-in-time compiler in mapping data. So when get data from database, I use just-in-time compiler to mapping in object. So this is impact to performance, to enhance CPU execution time, and then memory usage, and then CPU usage. This is I will to research again, because this all ORM not have different specific different for the result.
Okay, thank you, Mr. Aldi, for your answer. And then thank you also for your presentation. Let's take applause for the presentation from Mr. Aldi. Okay, so everyone, we will continue to the next presentation with the paper title Implementation of Semantic Search Base on Vector Database for Regional Personal Document will be presented by Ms. Namira Salsabila. For Ms. Namira Salsabila, you have 10 minutes for present your paper, and please present it, and the time is yours. Ms. Namira, are you ready?
I'm still trying to share screen.
Okay.
Is it okay now?
Okay, it's already presented on the screen.
Okay, thank you. Good afternoon, ladies and gentlemen. Thank you for joining this session. My name is Namira Salsabila, the primary author and speaker representing the School of Computing Telkom University, Bandung, Indonesia. I'm pleased to present this work alongside my colleague, Mr. Mas Wirya. Today, we will be discussing our research paper titled Implementation of Semantic Search Based on Vector Database for Personal Documents. This presentation includes overview, our approach, results, and discussion, conclusion, and future work. This section will cover the background, related work, and the goal of this research to provide context and highlight our objectives. Think about how we manage information today. In the 21st century, everything from office documents to personal notes has shifted from paper to digital formats, transforming how we store and access information. Traditional search methods often fall short. For example, have you ever searched for a document but struggled because you couldn't remember the exact keywords? Semantic search, powered by advancement in NLP and machine learning, address this by understanding the context of your queries. Vector database further enhance this process, handling complex unstructured data far better than traditional keyword-based systems, making them ideal for AI and machine learning applications. There are several key developments in document management and search systems. First, document management system or DMS play a crucial role in organizing and retrieving documents for both personal and business purposes. Second, vector database management system or VDBMS further enhance semantic search by managing document embeddings and matching keywords for more accurate result. Third, content-based search systems leverage embeddings to represent documents and queries, enabling more meaningful and semantic match. Lastly, techniques like hierarchical navigable small words or HNSW are used to efficiently index and retrieve high-dimensional data. The goal of this study is to develop a semantic search system for personal documents using vector database, overcoming the limitations of traditional search methods. Our aim is to enable users to retrieve documents more efficiently and effectively, allowing for semantic matching rather than relying on memory of specific file names or details. Next is our approach. The process begins by extracting and converting documents to PDF if needed. Pre-processing steps includes data cleaning, normalization, and metadata extraction. After pre-processing, documents are transformed into vector embedding using the pre-trained sentence transformer model, or mini-LM L6v2. These embeddings are stored in Milvus, a vector database management system, or VDBMS, with HNSW indexing for efficient retrieval. When a query is entered, it's pre-processed, correcting spelling and translation if necessary, and then embedded using the same model. The query vector is compared to the document vectors in MILFIS using HNSW indexing and L2 distance, returning the most relevant result along with metadata like title and author. The dataset used in this study was developed by the author with the help of ChatGPT and adapted to the study's context. It consists of 200 documents categorized in 10 topics such as professional work and personal finances. Most of the documents contain text and tables in Indonesian, with some including English. The dataset is divided into PDF and DAX formats to distinguish between documents that are still being modified and those in their final version. This system is designed to handle two types of queries: moderate queries descriptive with clear context, and complex queries requiring deeper semantic analysis. To evaluate the systems, we created a set of queries, 10 for each type, formulated in Indonesian to match the language of our dataset. For moderate queries, an example is a recipe document by Mama, while for complex queries, we used report on targets written when Jonathan was a teaching assistant. These queries test the system's ability to handle both simpler and more complex context-dependent requests. To evaluate system performance, we use precision, recall, and F1 score. Precision measures how many retrieved documents are relevant, while recall ensures all relevant documents are retrieved. The F1 score balances both metrics, offering a unified performance measure for single document retrieval. Next is results and discussion. So the semantic search method in this study achieves perfect score for each metric. Evaluations when applied to moderate queries. Also, if we look closely, you'll notice there's only one line because all three metrics are identical, causing them to overlap. The system consistently retrieves documents whose IDs match the ground truth, demonstrating its effectiveness in handling queries with straightforward context. However, for complex query, the system fails in query 2, document listing foods Jonathan shouldn't eat, because the target documents lists allergies without directly stating that this food should not be eaten. And for query 5, document comparing and evaluating two machine learning models, the system retrieves irrelevant documents because the target document focuses on comparing bird and distilled bird without explicitly stating that they are machine learning models. We also compare with OS-based search, Mac and Windows. Both Windows and Mac have faster response times than our approach, but their precision and recall are significantly lower. Windows relies on metadata like file names, making it fast but less accurate, especially for complex queries. Mac uses Spotlight, a content-based search engine, which improves accuracy but still lacks the semantic understanding needed for complex queries. Our approach using the Quen model for query refinement, so it takes longer due to extra preprocessing, but it delivers more accurate and relevant results, especially for complex queries that require deeper understanding. We also conducted usability studies, evaluated a system's performance from the end user's perspective. As you can see in the pie chart, we evaluated 4 key aspects of the system: ease of use, response time, satisfaction, and output quality based on feedback from
Before interrupting,
respondents.
Miss Namira, you
Yeah.
have 2 minutes left, okay?
Okay, output quality, ease of use, and satisfaction each scored 26.5%, while response time was at 20.4%. This shows that users found the interface intuitive and the search results relevant, but there's room to improve response speed for a better overall experience. So the conclusion, our system demonstrates the ability to deliver relevant search results with high precision, especially for moderate queries. When compared to OS-based system, our approach excels in accuracy, even though it requires more time. Additionally, usability studies reveal high level of user satisfaction with the system. While the current research has demonstrated the potential of semantic search using vector database, there are still opportunities for further development. Future work will focus on 2 main areas. First, optimizing the query preprocessing. Second, expanding the use of alternative embedding models. These are sources that contributed to this research. Okay, thank you for your attention. Feel free to ask any question and share your thoughts.
Okay, so thank you for Miss Namira for presenting your research. And also we will continue, and as usual, we will continue to the question and answer section. We have 5 minutes for the question and answer section. For the audience, if you want to answer, please don't forget to mention your name and your affiliation. And please raise your hand. Okay, there are 2 audience that want to answer a question. Okay, first maybe start from Osa Maulani. You can maybe turn on your camera and then please mention your name and your affiliation.
Wait, sorry, maybe my camera has problem.
Okay, just continue.
Okay. I want to ask you something for Namira. I have 2 questions. For question number 1, as you have explained earlier, the dataset currently used consists of 200 documents. In your opinion, how does the size of the dataset affect the system performance? For the second question, on a small scale, this system is capable of providing more accurate search result compared to US-based search. And however, if applied on a large scale, such as document search in companies with thousands to millions of files, what challenge must be faced and what solution can be implemented? Okay, thank you. It's enough.
Okay. Can I answer the first question? So, the first question is about how the size of the dataset affects the systems, right?
Yeah.
Okay, so of course, the size of the dataset certainly affect the system performance, especially in vector-based search. However, in this study, the main factor affecting speed is not the number of the dataset or the number of the documents, but the processing of the queries with large language model, as I mentioned before, is when. Because the search is conducted, the user's query must go through a typo correction and translation process, which requires additional time. Therefore, if the system is to be used on a larger scale, there are several optimizations that can be made, such as, like I mentioned on future work, is to use lighter and smaller LLM model to speed up query processing. Okay, so the second question is about how to implement it on larger scale, right? Okay, so right on a small scale, this system capable. But of course, the system can also be applied on a larger scale. For example, for document search in companies or institutions with a very large number of documents. However, to maintain this efficiency, several optimizations needs to be implemented. Maybe the solution I can offer is one of them is distributed indexing, which allows for more efficient management on large datasets. In addition, the use of GPUs or TPUs can accelerate the embedding and search process, ensuring optimal response time. Also, optimization on LLM, as I mentioned before, is also important so that query preprocessing runs faster without reducing accuracy. In addition, maybe the system can also be integrated with a document management system or DMS, like I mentioned before, so that documents are easier to access and manage on a larger scale. Like that.
Okay, thank you for Miss Namira for the question and answer section. Okay, due to the time constraint, maybe we need to move on to the next presentation. For the next presentation, let us welcoming Mr. Nur Rahmat Duirianto with the paper title Optimization of Object Relational Mapping Query Profiling Integration Based on Frequency and Timestamp Implementation and LRU. Is Mr. Nur Rahmat present in this meeting?
Yes, so in my own presentation.
Okay, thank you. The time you have 10 minutes for presenting your research. The time is yours.
Oops, we'll share my screen. Oh. Wait for a second. Can you see my screen?
Yes, you can continue.
Thank you. Okay, I would like to express my sense gratitude to the commit of the international conference. International Conference on Advancement in Data Science, E-Learning, and Information System 2020 for this opportunity. My name is Nur Diya, and my official is Siti Rahima. On this occasion, I'm about to present my research conducted under the supervision on my lecture. The topic is my research is optimization of object relational mapping query profiling integration based on query and timestamp implementation of LRU. Here are some outlines of my presentation for this occasion. Introduction, point of sales, application using object relational mapping to bridge the gap between object-oriented programming and relational databases, enhancing productivity, performance, and system maintainability, despite it benefits ORM frameworks, best performance overhead through the computational cost, translating object-oriented operation into SQL queries and managing relational mapping. Limited research addresses these challenges, but recent studies suggest optimization studies like division, data partition, in-memory mapping, and query refinement. To tackle this issue, this study proposed integrating query profiling and caching strategy with LRU algorithm. Query profiling identifies frequent execute queries, storing them in cache for faster retrieval, while the LRU algorithm efficiently manages cache data. The goal in our research have 3 points. The second goal to analyze performance overhead in ORM. Second, to propose a method query profiling based on frequency and caching strategy by applying timestamp on to the LRU algorithm. And the last goal to improve performance and mitigate the performance overhead of the ORM. Related study about the object ORM, object relational mapping, have been reviewed as part of my research, include the study conducted by Wang et al. Was HB Snipe tools to analyze and detect code smell in ORM. And also the next study conducted by Jovanov et al. The study introduced RQL, an algorithm to optimize ORM. And the next study conducted by Sotiropoulos, a data-oriented differential testing approach to testing object relational mapping system. And the next study conducted by Torres et al. Supply of 9 ORM framework. The next relevant study have been referred as part of my research is about the query profiling based on frequency, including research or study conducted by Mora et al. Analysis study to find out the analysis that aim to better understand the SQL server workload. And the next study by Peralta et al. Propose a method understand to detect coherent exploration SQL query workload. And Dunjewski proposed automated deterministic troubleshooting system integrated with statistical models. And also Bossi conducted a study proposed that ANOM, a query anomaly detection mechanism in database. And the last relevant study about the implementation of Template on ALRU proposed by Fochranger et al. Proposed WETT as allow overhead effective weight-aware, efficient, and scalable back replacement strategy designed for modern hardware. And the next study conducted by Peter et al. Performing replacement policy analysis for random case architecture. And the last study conducted by Inau et al. Proposed a case replacement algorithm method called multi-step ALRU. Our contribution is to propose new method which integrate query profiling based on frequency and caching strategy by applying timestamp to the ALRU algorithm proposed in the ORM framework, which has the objective function of improving framework performance and mitigating performance overhead. The research method, the methodology employed in this research is outlined as follows. The analysis performance overhead is involved comparing a native API client response time with the ORM API client response time. It is known that TORM, which is the total time response of API required to execute database operations such as CRUD operation spent by ORM API client, illustrated on the left of the video. It's known also TDB, which is a total time required to execute identical database operation using a native API client. By subtracting between two values, we can determine the value of the performance overhead introduced by ORM framework as the overhead. This is the proposed our architecture system named with Opti ORM ALRU, which is the ORM framework has been implemented our method with query profiling using based on frequency and implementation of ALRU in the ORM to validate or at the efficient more precise in the ALRU algorithm. This is OptiRMU method will be implemented in 5 point of cell project datasets, which were obtained from the GitHub repository. Experiment result. Following out the result, experiment analyzing performance overhead on the point of cell web API, the difference was found between the native API response time and the ORM API response time, where the ORM API has exhibited an overhead difference of 1.12 millisecond from the create operation or at customer, 0.35 millisecond from the read all operation or get all customer, and 0.56 millisecond from the read by ID operation or get customer by ID, 0.20 millisecond from the update operation or update customer, and finally 0.79 millisecond from the delete option or delete customer. This is the result of integrating a query profiling method based on frequency and the application of timestamp within ALRU algorithm for the web API of a point of sale system utilizing ORM. Performance testing was conducted on the POS system through load testing on the web API. The test involved a total 300 entities accessing using database operation method of read by ID. Testing was carried out by simultaneously sending 100 requests in single batch, and with each request targeting specific data among the 300 available entities in database. The evaluation was performed on 5 post-application datasets obtained from GitHub repository. We can observe from the 5 datasets that OptiORM ALRU has a significantly faster response time compared to the standard ORM and native APA. From the graph, it can be observed that the response from the ORM APA, which marked with the green color bar, tend to be higher compared to the native
Sorry
APA.
for interrupting, Mr. Ahmad. You have 2 minutes left, okay?
Okay. This is marked with a blue color, indicating the percent of operating using ORM. OptiORM LRU, which is marked with the red color bar, demonstrate performance of improvement with a lower response time compared to standard ORM across all datasets. All methods exhibit consistent response time different across all the datasets. Okay. Conclusion: the analysis of performance overhead result of current ORM framework found several overhead of response time than native APA client. The proposed of the ORM LRU method achieves super performance characterized by minimal response times and maximize throughput. To the integration of query profiling method and timestamp in LRU caching mechanism enables more precise data eviction and mitigating ORM overhead and enhancing APA performance across diverse testing condition. That's my presentation. Thank you.
Okay, thank you for Mr. Rahmat for the presentation. Okay, we continue to the question and answer section for 5 minutes. For the audience, if you want to answer Mr. Rahmat about his session, please raise your hand and then don't forget to mention your name and your affiliation. Thank you. Okay, we have Mr. Akmal. Okay, Mr. Akmal, please mention your name and affiliation, and it's better if you can turn on your camera, and please mention your question to Mr. Ahmad.
Okay, before starting, can you hear my voice?
Yes, I can hear you.
Okay. Sorry about my camera. It doesn't work. I don't know why. So, I just appreciate your presentation today. I just mentioned about ORM framework. Okay?
Yes.
So I just interesting about ORM framework you mentioned today. At least I have at least 2 questions. For the first question is, how does the ORM framework impact the overall performance of the application, and what metric are used to measure this impact? Is based on your methodology slide. Maybe it's our question today.
Okay, thank you for Mr. Akmal for the question. Okay, Mr. Rahmat, you may answer the question. You have 5 minutes.
Okay. The point of your question is about the impacting our method in ORM, right?
Yeah.
Impacting in our proposed method is but in significantly in response time in web APA point of sale, especially in the truth operation, because in my research I found a performance overhead in ORM with the load testing using Gmeter and have the different response time between the APA native client and ORM APA native ORM APA client, which is it is the point of why I conduct this or propose our method, because to mitigating or resolve the performance overhead in ORM. Right. And after I implement our proposed method using query profiling based on frequency, and timestamp in algorithm, or also implement algorithm in the ORM framework, significantly can remove and mitigating the overhead in ORM. As before I testing the ORM, before implement my method. That's my answer.
Okay, thank you. I got it. Yeah, I got it. Thank you for your explanation today.
Okay, thank you for Mr. Ahmad for the answer. Okay, because due to the time constraint, we just only have 2 minutes left for the question and answer. So it's better to continue to the next presentation. Thank you for Mr. Ahmad once again. Okay, for the next presentation, we will continue to the next presentation will be presented by Mr. Okay, wait for a minute, sorry. Okay, Mr. Tanvir, sorry. Mr. Tanvir with the paper, with the title. Sorry,
Yes,
I have a
I'm ready.
technical issues right now. Okay, sorry for the issues. Okay, for the paper with the title, Exploring Corporate Law Violations through Data-Driven Clustering Approach. You have 10 minutes for presenting your research. The time, the place, and the time is yours, sir.
Okay. Thank you so much, everyone. So my name is Tanvir Ramadhavdar. So for this presentation, I want to explore the corporate law violations through the data-driven clustering approaches. I did with my 5 members. You can see here, and my name is Tanvir Ramadhavdar. We prepare it in a different way. We will maybe talk later for the challenges if you want to ask, but we want to first present this one. So for this one, key findings on corporate law violation clustering technique is utilizing clustering techniques for enhanced regulatory compliances is complexity of corporate law violations, rolled up predictive models, clustering techniques utilized, identify the high-risk entities, develop the legal practitioners and a novel approach of legal compliances. So for this one, the study purpose of novel approach for addressing corporate law violations by combining subject matter expertise with a data science technique as a unsupervised learning. So predictive models serve a critical component monitoring potential violations of corporate law by analyzing historical data trends, and organization can proactively identify the risks. And in an overview for this, understanding the implication of analytical strategies in law violations. If I define the corporate law violation, it is all about including frauds, tax evasions, branches of labor, environmental laws, and impact of the globalizations on the legal compliances is across multiple phase increased challenges in adhering to the verifying law, which can lead the higher instance of violations. So importance of clustering techniques by identifying the patterns in the fraudulent activities, those techniques can help the organization detect and prevent illegal infractions. And the role of domain and knowledge of clustering is approaches ensure the instance driven are actionable and align with the legal standards. Limitation of clustering technique is poor data processing can yield the misleading outcomes, and enhance the proper cleaning and parameter optimize are crucial. In a traditional risk mitigation approaches is classical methods such audits, whistleblowing has historically used to mitigate risks associated with the corporate law violations. And for this, we use the machine learning in the law enforcement. So it integrate the SNN clustering techniques. It's collaborate with the law enforcement, clustering and predictive analysis and methodology for corporate law violations, pathway corporate law violations, important of domain refinement. So this study identified the major pathway through which corporate violation occurs and highlights needs proactive measures to mitigate risks associated with the corporate governance. For proposed methodologies, if we first create the new corporate law data and all those things are connected with feedback loops, it's easy to resize the data. And in this overview, clustering algorithm and data analysis, business legal interactions is data collection, data organization, data cleaning, feature extensions, data transformation, model fightings, automated tools, and crime forecasting. So in utilize this model, AI and machine learning techniques models are fitted to the transform data and predict crime patterns. This process enhances the model accuracy, provide instance the potential future crimes such homicide. For the proposed methodology, we just introduced the PSO and GSM method. So this method combines the practical swarm optimizations and the search algorithm, enhance the clustering efficiency. So for enhance the speed is achieving a remarkable 71% increasing of performance compared to traditional signals classification algorithm. And GPU-based computation is the technological advancement of crucial for headlining the vast amount of data granted modern resources. And integration of optimizing algorithm is analyze the complex data visualization effectively. And original contributes of research. The research introduced the original contributes through the implementation of PSO and GSM mechanism. So this innovation approach has the potential to global optimal research significantly earlier than previous methods, showcasing the importance of original work in the field. So for objectives, is leveraging the data technology enhance the compliances. Is use of the case law dataset clustering techniques, clustering method applied, predictive analysis, AI decision making, benefits of stakeholders. So and integration of conventional measure with machine learning. So if I wanna talk about the benefits, this regulatory bodies, policymaker, the key stakeholders in here. So who can benefit from the instance, and corporates can improve legal compliances by mitigate the persistence legal risks. While policymaker can establish the guidelines that address recurrent issue across the multiple cases. For BI clustering techniques and machine learning, so it's examine the intersections of BI clustering and machine learning in corporate law. It's if I want to talk about the BI clustering, it's about analyzing G expansions data and revealing how attribute reveals can shift among the clustering. This adaptability enhance the data classification by providing deeper instance in the complex biological system. And impact of data classification is can achieve more accurate classification reflects the underlying biological process. In a machine learning, in this corporate law is hiding the correctional scripts that may go unnoticed. These techniques play a critical role to identifying the potential corporate law in fragments. And the application of fraud detections is clustering method that applied extensively fraud detections and proactively identifying the fraudical activities implements the compliance measures. An instance for the crime control studies is this approach have shown the promises detections and analyze infraction against the corporate laws. If I want to talk about evaluations of matrices of clustering, this a high score, and for examples is signifies the
you have 2 minutes left, okay?
amongst the same clustering compares this other clustering. We have a quality clustering instance, feature extension progress, normalization techniques. This is essential to standardize the data attributes, providing the large values like financial matrices techniques such as max min scaling and J-score normalization commonly used. So K means clustering overview, clustering techniques, hierarchical clustering benefits. In a result analysis, if I go incorporate expert instance, this new data and expert comments are integrated into the clustering process, ensure that models remain relevant and reflects the current trends in the corporation compliances. This expert input the vital for refining the analysis and significance for the policymaker and corporations and future instance and normalizations. This is for clustering classification characteristics. So significance, compliances, regulators, and policymaker. So targeting the non-compliances entities through the cluster analysis. Risk zone identified.
You have 5 seconds left.
And this is our key instance. In conclusion, it's important for clustering techniques and future research directions. Future studies should consider assembles modern supervised model for violations as well as expanding dataset borders conclusions.
Okay.
And this is the reference. Thank you.
Okay, sorry, the time is up. So we continue to the question and answer section for Mr. Tanvir. Okay, so for the question and answer section, we have 5 minutes for question and answer. For the audience, if you want to answer Mr. Tanvir about his research, please raise your hand and mention your name and affiliation. Thank you. Is there any question for Mr. Tanvir? Okay, I think there is no question from the audience. Okay, I will ask Mr. Tanvir, what is your challenge when you do this research?
Okay, thank you so much. When I started, I talk about challenges. My first challenge was all team members who are working in a different area, and we it's too hard to manage our times because we are in US right now, so it's too much hard for our manage our time. And the second thing is refining the clearly define the research problem. So, what is specific corporate law violations are being targeted. So we have to analyze this one too hardly. And we try to provide the real world example or case studies in a corporate law branches. And for the in a literature review, we try to compare clustering techniques with other existing method of corporate compliances like rule-based detections, anomaly detections. So we try to discuss the previous research to corporate law violations, how they study those findings areas, and enhancing the methodology we just try to clear explanations of the data sources used for clusterings for justify the k-means and hierarchical clustering we chose over the techniques like Gaussian mixer models, and we also try to explain how the data pre-process was done. So it was too hard to handling the missing value and features the section and normalizations. And we try to improving our result sections, and we try to use more visual representations like graphs, heat maps, clustering diagrams, and we try to find the real spread, but we just try to manage. So we also try to compare the clustering outcomes, the actual regulatory case, and effectiveness. Provide the confusion matrices, accuracy matrices if the validation method was applied, and we also utilize the clustering models used in k-means. If I want to example for k-means clustering, we try to put why we use it. Like k-means is efficiency, we widely use it. So the algorithm is easy to for identifying the similar pattern of the data. So it helps our group and communication entities based on the likelihood and violations corporate laws. And we try to understand so how it works. So the algorithm assign the entities and k difference clustering based on the feature similarities like financial record, legal histories, compliance scores. In companies with same clustering execute a similar companies behavior, allowing the regulators identifying the high risk clustering. So this kind of challenge we face a lot.
Okay, thank you. Maybe the last question before we close this parallelization, or maybe why you choose clustering instead classification?
Sorry, ma'am.
Why you choose the clustering method instead the classification method?
Oh, the k-means clustering is it is the most efficient and widely used. So it's easy to algorithm for identifying the similar pattern of data. So it helps the group and companies based on the violation corporate laws. So that's why we use that one.
Okay, thank you for Mr. Sanford for the answer. Okay, so we have finally reached our final presentation in this parallel session. Before I close this parallel session, it's better for us to take a documentation. So please, for all the presenters in this room, to turn on the camera to take a documentation.
Okay. 1, 2, 3. Again. 1, 2, 3. Last one. 1, 2, 3. Okay, thank you.
Okay, so thank you everyone for gather in this parallel session on G4 room. So thank you for everything and your presentation. And ladies and gentlemen, this concludes the parallel session. On behalf of the ICADEIS Committee 2025, I would like to thank you for all our presenter for their exceptional contribution and insight. I would like also to extend my gratitude to all participation for their engagement and thought-provoking questions. We hope this session has been both informative and inspiring for us. Before we close the session, we conclude this session, thank you once again, and I hope you had a wonderful day. Thank you, everyone. Good job for all of you.